Takže, vítam vás na druhej. This talk will be in English. So, welcome to the second talk of the day. In this yellow room, the talk will be from Vojta Filipec. The name of the talk I cannot pronounce. So, Hypotrochoid curves as a web app. So basically, Vojta came out with something like, he will explain better, but it will be a no-code or low-code example of something that was previously done in Jupyter Notebooks. So he is able to move one step forward to a no-code example of some physics exercise. So give a warm welcome to Vojta. Please. Thank you very much.
Thank you for the introductions and nice to see so many people coming. Yeah, my name is Vojta Filipec and I will show what hypotrochoid curves are and how you can program them in Jupyter Notebook. The talk has two parts. First, I will speak about spirograph. What spirograph is, it's using the slang nowadays, it's a smart toy, but I had this toy as a child. Those days it wasn't called smart toy, it was simply a toy. And then I used to play with it a lot, and I lost it as I was growing old. And now as an adult, I can have spirograph as a web application. And you will see it's a web application which any of you will be able to code after this talk. A bit about me, I'm a nuclear physicist by training, and I've been in the field of data science since ages, long before it was called data science. If you want to contact me after the talk, just come to say hi or shoot me a message through LinkedIn. And if you're interested in these slides, they are at my GitHub. So it's github.com/Wojciech-Filipec. You will find those slides there and also the code I'm going to show. So what is a spirograph? That's the first part. It's basically a toy which consists of two main parts. So the first main part is one or more of these large wheels which are supposed to be pinned to the paper, right? You select the wheel, pin it to the paper, and then you see it's a cox, it has cogs, because the second important part is a set of these small wheels, and you select one, place it inside of the large one, and then if you look carefully, it's quite visible here, each of those small wheels it's torn. There are holes in those small wheels. They form a spiral, but that's not really important. The spiral just shows you that they are in different distance from the center of the small wheel. So some of them are at the edge, some are more towards the center. And if you put the small wheel into the large wheel and place a pencil into one of those holes, you simply start rolling. And Wikipedia has a nice animation of this. You see there is a red pencil in one of those holes in a small wheel, and as you're rolling, you're creating this pentagonal curve. And whenever you create a curve by rolling one wheel in another wheel, that's called hypotrochoid. And this pentagon is one of possible hypotrochoids. They can also look like this, or if you use different small wheel, it can be this shape. This is pentagon in another form. This looks, I like this one since it looks like two intertwined curves, but it's really one smooth curve. This looks like some oriental motif, or this is what my children call Daisy. Yeah, so that's it. It's surprisingly simple, large wheel and small wheel, and there is a math behind this. These two equations are from Wikipedia, and they basically tell you the shape of the wheel, or shape of the curve, or how it looks like. It's defined by 3 parameters. What matters is the size of the large wheel, expressed as a radius, then size of the small wheel, that's this small case r, and then d is the distance between the tip of your pencil and the center of the small wheel. And with these three parameters and these two equations, you basically can say, as you're rolling, you're changing this theta angle, what are the coordinates of like horizontal and vertical, x and y, at any angle given those three parameters, capital R, small case r, and d. Right, so that's the first part. I promised to speak about hypotrochoid curves. You know what they are, it's this family. I was speaking about sinus and cosinus. Yeah, these two equations, it's simply linear combination of cosinus for x and sinus for y. And I was speaking about beauty. I hope you are excited as me. I really find these curves beautiful. Also, as a mathematician, I am enlightened or surprised how simple these two expressions are. And then the title was speaking about the web app, so we're coming to the second part, how to program this as a web app, since it could be that some of you have this toy at home. That's not my case, unfortunately, but I'm really sure anyone can code this as a web app. And it's as it was introduced, it's a web app which comes actually from a Jupyter Notebook. So I would like to make a poll here. Who of you have worked with a Jupyter Notebook? Please, hands up. Oh, fine. And how many of you can write a web application that is shareable with the world and you can deal with the hosting? Quite few people, definitely not me. So I am sure that after this talk, you will know how to take your Jupyter Notebook, how to remake it into interactive, no-code web application, and how to do the hosting. So I have a demo prepared. It's this thing, right? So this is the final product we will be talking about. It's a web application which tells you what hypotrochoid curves are. Sorry, the text is small. I will make it larger. Works? Fine. There is a link to Wikipedia to this animated GIF, which I really like. And then the interactivity is here. You know that our curve is defined by, or these hypotrochoid curves are defined by three parameters. This is a capital R, small case r, and d, the distance between the pencil and the center. And I have added the color of your curve. And whatever you select here, you can push this plot the curve, and it truly plots the curve. I will try to change the large radius and also say the small radius, plot the curve, and you get another curve. And I'm really excited that this works in an environment where, you know, this is not a Jupyter Notebook. It's web app for people who never worked with Python. You don't ask them to work with the cells and the run cell by cell. I want to show you what's behind this. That's the other live demo. It's this notebook where there are cells here, which you all know. This is a cell with commands. There are imports here. This is cell with markdown. Oh, I can actually run it all. Somewhere below, right, here is the cell with the interactive elements which we saw in the app. And this, you know, this is a classical notebook. I believe this is what you know, right? When you think about Jupyter Notebook, it's working as in the app. Oh, this is a special case when the small circle and the large circle have the same radius. So if I show it by hands, if it's the same, it can't really roll. So this is a special case of hypotrochoid curve, which is a single point. There are more special cases which are described somewhere here below, but I will go with 5 and 4. Right, that plots this thing. So that's it. Having this notebook, which has these sinus and cosinus functions, imports and drawing, you can get this web application easily. And 3 things I want to highlight at the application. I have noticed it, but really this is the strong thing. First, it's interactive. right? The users can use these radio buttons to change the radius on the distance and push the button plot the curve, and it plots the curve. Second, it's truly a web app with no code. You don't show the imports or any, when you want, you can show any cell with the markdown, but you typically don't want to show the code. So you can send it to your children or to your grandma and tell her you can play with this. And the third thing, this is worldwide accessible. I'm hosting it somewhere on, we'll speak about it, it's called Binder service. So you can really send it, it's not only one-man show on your computer, but you can send it to people worldwide. And I'm using these curves as an example, and it's probably no practical use. I was showing this at one interview, and the lady was telling me, okay, but what's your business here? How will you earn money on this? I said, no, this is just for fun. Yeah, true story. But what I want to emphasize here, you can have this really for some either profitable thing, or you can share this with your friends to make a poll, right? To vote for when will you meet before the Christmas. Or you can have a text box and ask your family members on your cell phone, please submit your expenditures so that we know how we are doing. Simply, all you need to prepare is that Jupyter Notebook, and I will show how to remake it into the app. So these three things, interactivity, no code, and hosting, are the topics of the second part of the presentation. So for the interactivity, you saw that notebook, that these are cells, type of cells you probably know. This is a commented code. These are imports. Then I have a markdown cell. And this one was a bit special. This was a cell which produced these radio buttons. These interactive elements are called Jupyter widgets. And this is the first learning. Your notebook must include these interactive widgets if you want to make it an interactive app. Is this new for people here? Please tell me. Who of you are hearing about Jupyter widgets for the first time now? Fine, fine. So you are in the right room, and I have the right audience. Yeah, I guess typically, if you wanted the user to define capital R, what I would do before learning this is include a cell, which would say in a comment, specify capital R here, and the cell would read R equals, and the user would need to plug a value in. Well, these widgets, once you import them, you basically get a family of, well, widgets. It's buttons, radio buttons, sliders, progress bars, drop-down menus, whatever you come up with when you think about interactivity. Let me show you how it works. It's really simple. So from these widgets, can you read it, this code, please? Yeah. I'm instantiating a class button. I say I want this button to hold a description which says plot the curve, and I'm saving it in an object called button. And later on, when I call this button in another cell, it generates this button with the description, plot the curve. This is another beast of widgets, radio buttons. So I will say I want a set of radio buttons which have these options like values. I have prepared the list of R's that were values 5 through 13. It will be described as a R, it's enabled, and the default value is 5. I'm saving it into an object called cell R, like select the capital R. And then later on in cell 27, I'm calling cell R, and look what it generates. It's a set of radio buttons with values 5 through 14. That's what was in the list. The description is R, and the default value is 5. It's really that simple. You don't bother with any JavaScript. You just import the ipy widgets, and that's how you define them, and that's how you display them. And if you check my slides, this is a link to the gallery of widgets. There are, I would guess, 40 of them. One of them is a dialog for uploading a file. So if you want to prepare this for someone to upload their selection of colors and plot the curves with those colors, you can do that. So the learning here, interactivity is embedded through Jupyter widgets. Now the second thing is voila. So once your notebook has these widgets, you still only have the notebook. And I will read this. Voila is a framework which turns Jupyter Notebooks into standalone web applications. Voila is the thing which takes your notebook and projects, shows only the interactive parts of that. It's that simple. You basically install voila by pip install voila, and then in the same terminal you call voila and name of your notebook. And the result is a local run. That's the demo I was showing here. I will refresh so that you see now voila is loading. It loaded the notebook, and as I was showing before, you can play. It's quite smart in a way that if I change something in a notebook, I can go here and add, say, print hello world, right? Or just hello. You don't need to do any special, and now I don't forget to save it. You don't need any special setup. If I now refresh my app, you should see that text hello. Can you see it here? So no special long-lasting starting of that. You simply save the notebook and your output is here. Right, so voila results in a local run of that notebook. Not sure whether you can read it, but the URL says localhost at port 8866. And what it does, if you compare this with the notebook, voila only displays output of these cells. And that's really important, because you see my first cell was this cell with commands and second with imports. If I run these cells, they don't produce anything, right? There is no output section here. And only this cell, which contains Markdown, produces a Markdown text. Now I will switch to the app. This is the cell with the Markdown. Those two cells above, which had the imports and comments, are not here. So the important learning at this slide is, first, voila projects your notebook as a web app, and voila displays only outputs of these cells. That's why you saw radio buttons and Markdown, but no imports, neither definition of functions. Now, it feels like it's confusing. Am I getting it right, or is it clear? Yeah, thanks. Feel free to approach me if this was not. Voila has a nice logo, so I included it here. And two links which show you how to set up an example project. Feel free to clone this project of mine, that's fine. But if you wanted to try something more elaborated, please refer to these links. And as I said, the result of voila is a local run. We are on my local host. So I could invite you to come and play with the curves, or I could hand it over to my children, but I couldn't really send it to my friends in different country, city, continent. So the third thing we are going to learn is how to share it with the entire world, and that's through a binder. If I say binder, does it ring a bell? Have you heard about this binder service? Who has heard about this, please? Okay, not so many, perfect. So this is really relevant. So binder is a free web service. They have a web page which is linked there, where you can basically show your repository or share your repository with the rest of the world in executable form. How does it work? You basically come to this dialog, which is on the binder page, and say, on a GitHub, I have this repository, Wojciech-Filipec/Hypotrochoid curves, and I want you to show the curves notebook, and you can even say which commit. Upon clicking the launch, Binder clones your repository at the Binder server, at Binder infrastructure. Then it runs, I think, a Docker container with Ubuntu. Well, simply it prepares the infrastructure for running your notebook in Jupyter Lab. And after a while, it really prepares the Jupyter Lab with your notebook. And this is all happening on the Binder server. And you are getting the Jupyter Lab through web browser. So all the heavy lifting is done by Binder, by their hardware, their server, and you are sitting at home with your computer, and you're getting, as you know, Jupyter Lab in the browser. But contrary to my lab, which is running on my local host, you would see a web address of the Binder server. So the message here is Binder is good for hosting the notebooks. If you want to have Jupyter Lab, which is not served by your computer, but by some other server. Feel free to use it with any free repo. You can use mine. And now I said it's for sharing notebooks. And the killer feature here is that Binder supports Voila. Right? You remember Voila is the framework which projects your notebook as a web application. So not only you can share with your co-programmers your notebook, but you can really get this application, this is the no-code, running for anyone in the world. Binder in their server will take care of rendering it, and will just send this application to the client, which is, I mean, computer of yours or your friend. So I find this really strong, right? I don't know how to host web pages anywhere, but I can work with dialogue like this, and now I believe each of you will be able to replicate it, and the result will be web application shareable with the entire world, remade from a notebook. And see, we did no front-end work. We didn't have to take care of the hosting or security. That's what Voila does and Binder does. That's basically it. To wrap up, we have remade Jupyter Notebook into web application. We first brought interactive elements through Jupyter widgets. These were the radio buttons or the push button. Second, we used Voila to remake the notebook to the app. And when I say a remake, I don't mean that Voila would take the notebook, transform and save somewhere. It's really running the notebook in the backyard, and what it shows are only the outputs of the cells. And then the third step is to load your notebook to GitHub and go to Binder and say, please serve my notebook through Voila. And in the end, you will have your web app running in a publicly accessible infrastructure which you can share. It's really it. I want you to know about two alternatives here. So interactivity, I'm promoting Jupyter widgets, but the other options are Panel and PyWiz, or Marimo. If you have heard about Marimo, I would like to know your opinion. For me, Marimo could be a replacement for Jupyter Notebook, since it's a smart notebook, which, you know, in Jupyter Notebook, if you have 100 cells and then change something at the beginning, then you don't really know, do I need to run all the cells to the bottom to continue with my work? Well, Marimo keeps track of what cell depends on what other cell. So if you are at the bottom and you go to the top, change something there, then Marino reruns the relevant cells for you. I'm really happy about this feature. And there is a workshop on PyWiz, Panel, and Marimo on Sunday at 10 in the morning. It's taught by Michal Kaukic, and I thank to Michal for taking my repo and redoing it into Marimo app, which is accessible here. Thank you for this. You can check it and compare Jupyter widgets and Voila versus, yeah, Michal is here, hi, and Marimo. So these are the alternatives for bringing interactivity. The second alternative I want to mention is a hosting. So I'm using Binder, and just in the recent week, as I was preparing this, Binder seems to be running out of resources. So I can't really show you that web app on World Wide Web. It's really my local run here. But Voila has a nice section of documentation which shows you what other engines other than Binder are accessible for hosting the apps through, apps, hosting the notebooks through Voila so that they act as apps. That's really it. I'm opening the floor for the questions. Thank you.
Thank you, Vojta. So we have questions. First one, I'll just walk around. It's very interesting how people that never encountered, web frameworks and HTML and stuff could do stuff. That's very nice. So are the Jupyter widgets available in Google Colab notebooks as well? Do you know something about that?
I do Google Colab notebooks, but I don't know whether they support Jupyter widgets. So sorry, no answer here.
Yeah, that's fine. So what happens when you encounter a runtime error in the app? Or you get some endless, infinite loop or something like that?
It's exactly the thing that would happen in the notebook. And I can see two types of errors here. So one is voila, you have a corrupted version of voila, and it's not processing your notebook correctly, right? Then on this screen, right, I will reload the voila. Here you see how, sorry. Thank you. I am now reloading voila, and it could be that if voila is corrupted, this reload will not take place. Never happened to me, yet it can happen. You are using a complicated thing. And then you could also have an error in your Python code. So I'll go back to here, and I will, let's say, I will import some library which doesn't exist. So OS Vojta, I'm sure this doesn't exist. If I run this, I get an error, right? I'm saving my notebook now, and I will reload voila. And what you can anticipate, the voila will reload the notebook, run the cells, and the first cell will generate an error. So we should see that error here. That's the thing. So it ran the first cell, then the second one was producing an error, and there was an error in executing. Can you still see it? Sorry.
Yeah, could you perhaps add there was a range from 1 to 16. Can you add there 0? And so you can see some division by 0. So you have like interactive, you trigger some edge case after the notebook is loaded.
Okay.
Yeah.
Thanks. I will cancel this, and I'm looking for some division. So here, so I will take capital R should be 0 so that it fails. So options for R will be range 10. Saving the notebook, reloading voila. Right, so I will use capital R0 and plot the curve. Right, so, and I will try to do the same in the notebook, right, so that we can compare what it does. Run all cells. 0 is here. Looks quite the same, doesn't it? So, thanks. I really want to highlight that voila is not doing any. Like they say, we turn Jupyter Notebooks into web application, and this sounds to me like we download your notebook and translate it to some JavaScript application, but that's not the case. They really take your notebook, run it, and only display output of the cells. So there is no translation. It's really just running and displaying part of that. So it's one-to-one.
Thank you. Can we switch to the Slido screen, please? Okay. Can you store user-created data in the web app, like browser, session, storage, which is...
Yeah, this is something I'm actively working on, since I want, these curves are nice, but they are on a screen. I would like the user to have an option to save that image and have it stored somewhere. And it's not that simple. There is a Jupyter widget which allows this, but it's some custom, it's not one of those basic widgets. It's some custom implementation, and I haven't had time to deal with that. But eventually it should be possible. Whoever asked this, feel free to approach me. I can show you what I have. It's possible, people say, but I was not able to work it out yet.
Thank you. For latecomers, could you recapitulate? Is that the word? What notebook? Yeah, there is a, when you use Slido, there is like a enhanced feature that will reword your sentence into better English. Could you recapitulate what notebook jesus.org does? Thanks.
Yes. So I was speaking about Binder. And if you go there and say, I want you to serve this notebook through Voila, you click that launch button, you remember that dialog, and suddenly what happens is that it forwards you, Binder forwards you to one of two servers. One is called Jesus, and the other one is OVH, I think. Simply, Binder does not provide servers per se. There are companies sponsoring Binder, and they are offering their hardware for this heavy lifting and for serving. So Jesus or the other one, I think it's really OVH, like Ostrava, Vitkovice, and H like Havirov. These are two providers of the hardware. And yeah, I said that they seem to be running out of resources, so it could be that you will see the third provider too. But it's just the company which does the hosting, full stop.
Thank you very much. Any other questions from the... Okay, I'll give you the mic.
Thank you. I have a question about widgets, if we can return to that slide or that notebook. My first question is why were you defining hbox cell R? Yes, why disabled is false? Does it mean disabled is true by default? And next question, what if default value is out of the range defined in list_R? Thank you.
Thank you for the question.
Thanks. So first, this disabled feature, it's for fine tuning. If you have many many widgets, it's getting computationally expensive. So I think that's why they built it in. All I know is that it's for if you're tuning your notebook. I simply took the code from the widgets repository and I copied it over. And then this default value, the answer is I don't know. Let's try it. May I pass you the mic and try?
Yeah.
Here, default value. Thanks. So we are in the definition. I will make it larger. This is the code I copied, right? Radio buttons, range, and so we have range to 10, so the value would be 11 now. I run this, stop iteration. So I save it and I will reload voila, and I'm expecting the same error here. Looks like there was an error when executing cell 9. And sorry, this is cell 36, so I will delete or rerun it all. Kernel this thing so that we know whether it cells 9. Right, it was cell 9 which produced this error. It was translated into another error in voila. Yeah.
Okay, so something like that. You can also always talk to people later after the talk. So I think, run out of time. So thank you very much again, and see you later. Thank you.
Thank you.